Well, this is tubalcain, Mr. Pete 222. I'm back again. New day, fresh start on the little STARRETT tap wrench, and I'm ready to start the screw today. But before I do, I just wanted to say that I put this on my scanner, or you could do it on a Xerox machine, copy machine, whatever, and change the size, change the scale. This is it at 100%. There it is if you want it a little bit longer. At 115%, and then you can scale it right off of this with your ruler. Now I know that's against the law to scale things, but I do it all the time. There it is at 125%, and that gives you a wrench that is about almost 4.5 inches long, or finally the last one I did was 135%. And that gives you a 5-incher. So that's just food for thought. On with the job. Alrighty, here's how I'm going to make the screw. This is 3/8 diameter. This is 3/8 diameter free machining stock, 12L14 that I got from Hobby Metals. Bernie at Hobby Metals, he will meet all your needs. So the first thing I want to do before I thread it is to knurl it. And you can see that I'm going to put, or I already have on this sample piece here, 2 inches of knurl, and most of that's waste knurl, because this piece is approximately 2 inches long. And then I will turn it down and thread it. Remember, that's 12/24. So let's step over to the lathe and do a little knurling. I'll do it on the other end of this. That way I got a spare in case I would goof it up. Not that I would ever goof up a piece. On the subject of knurling, not everybody has success with knurling, or knows how to do it, or has the tooling for it. But an option is to make that end piece out of hex stock, not brass, but out of hex stock, and that would work just fine. Now, I think that everyone in all of Christendom knows that I loathe this type of knurler, so of course I am using my Brown & Sharp pinch type knurler, as it is my wont to do. And I had spent over an hour changing the knurls. That's the rolls. That's what I don't like about this. It's no easy job to change the rolls and then adjust it for whatever your diameter is. And I had way too fine of rolls in there left from some projects, so I went and put the medium. These are the fine ones, which were way too fine. Alright, enough gabbing. Let's knurl. I like to run the machine at a slow speed in back ears. It's about 400 RPM with about a medium feed. I'm using power feed, plenty of oil, and usually a rag or something down here to catch that oil. And I'm going all the way up to that black line. It's about 2 inches. Reverse the feed. You need oil on the way out too. It is warm. I'm over on the Atlas lathe now because I did not want to change the setup on the closing, but notice that you never want to hold the knurl in a chuck, and I was considering holding it in a collet. I had a collet in here before, but of course knurling produces an oversized piece, so it will no longer fit in a 3/8 collet. But essentially this is what I'm doing here. This, I told you, is all waist knurl. Turning it down to 216 thousandths, which is the OD for a 12/24 thread. And I might not have mentioned, but a 12/24 thread is very close to 7/32, but yet it is not 7/32. 7/32 is 219. So a lot of those dimensions were oddball. Now if you do not have 12/24, you could use 10/24 or 10/32, but that takes it down just a little bit where I don't like it, but it'll probably work. But 12/24, and I'm going to use a die, but I will turn it down, and I have already off camera drilled a center hole because you will need some support, because we're turning it down to a rather slender diameter that no doubt will flex if it's not supported. I step away for a drink of coffee, and I already forgot whether or not I told you something, but that's about 1.25 inches worth of thread, and I did indeed set my carriage stop. I like to use a carriage stop if possible, and I'm just using high-speed tooling here. You know, it doesn't matter what your cutting tool is, and I'll use power feed and take it down to that dimension I just told you. This is the last pass, it should be. I'd rather be a couple thousandths under. It makes threading just a little bit easier and will not affect the performance at all. I'm 217. I'm going to take another pass without increasing the feed, and that'll take me down. I won't show that. I'm in back gears. This is the 12/24 die and a little tailstock die holder, and I'm ready to thread. I use plenty of oil, and once in a while I stop and reverse it. This lathe does not have a reversing switch, so sometimes I just stop it, take it out of gear, back it up like that to break the thread, and I'll thread all the way up to the shoulder, or as close as I can as possible. I might have said break the thread, I meant break the chip. Because this is not really a power die, it's a hand die, so there's a tendency for the chips to jam up in there compared to Don't try to do this in the vise with a hand die stock. You'll get a crooked thread. It's got to be done in the lathe. And now I'm checking the thread. I blew it off so it's clean with the workpiece just to make sure we got a fit. And I do. Goes all the way up to the hole. Next, while the work is still in the 3-jaw chuck, I'm going to ream a 5/32 hole in the end, 3/8 deep. So this is a drill bit one size under 5/32, whatever size that is, and I'll explain why I'm doing that in a few minutes. And now the reaming, 5/30 seconds. Now I'm at the drill press and the work is in my drill jig, and I plan on drilling this 5/30 seconds cross hole. And I think you can see the advantage now of having the extra long piece, so I got something to grip in this jig as well as the lathe and other operations that I'm performing. So I'll clamp that down, and this, you've seen me use this many times, just assures a perfect cross hole without going off the side or at a funny angle. And there it is, a perfect cross hole. Now I'm ready to cut it off right at the end of the knurl and face that off. And I'll talk about the end hole. So in review, this was a 5/30 second hole, cross hole, and that drill jig did press on the knurl a little bit and cause minor cosmetic damage. Minor is right. And then remember, this is reamed 5/30 seconds, 3/8 deep. I'll talk more about that in a minute. But right now I'm going to cut this off just in the vise with a hacksaw, then put it in the lathe, face it, and then put just a little bit of a crown on it. You see, that's not perfectly flat, and I'll have to do that with a file. I have no special tool, but that gives it a nice appearance compared to just being perfectly flat. So let's go do that. Facing off, and then just a little bit of a crown if I can. This is the original STARRETT piece, and you see that on the end, I showed that before, they have a straight section with a little bevel on it. Well, my reading on that is just a little bit different, so I'm taking a hardened 5/30 seconds dowel pin, and it will be held into the 5/30 second hole with Loctite, and I'm going to cut it off right on the red mark there with my Dremel tool. So I'll do that first and then Loctite it and let it set for a while with the Loctite on. Okay, I've cut off that little 5/30 seconds dowel pin to a short piece. Just a couple drops of anaerobic on here. And that's not going to go anyplace because all the pressure is this way anyway. But you can see now the similarity to the STARRETT. Alright, well that's setting up and it doesn't take long. I'm going to cut off the project from the parent metal. I got a mark, and I just marked that right off the STARRETT, but for those of you that may be making one of these, the overall length here is 3 1/8. 3 1/8. Again, I'll cut it a little bit longer than what I need and put that beautiful crown on there that Leroy STARRETT came up with in 1872. How will I hold this? Because it's rather irregular and you certainly can't hold it on the taper. So this could be held in a 4-jaw chuck, but it would take several minutes to set it up unless you had Adam Booth to do it, who could do it in 30 seconds or less within 1/1000th. But since we still got our round, or I should say our radius here, that's a 7/16 collet, and I'll just chuck it up like that in the Atlas lathe. This is one of the very last operations, so be careful not to bend the work. This is the weak spot, and there's more sticking out of the chuck than what I would like. heartbreaker to ruin it at this point. And then the crown. I would like to digress, with your permission, on Starrett tools just a little bit while you guess which one of these is the homemade and which one is the Starrett. You saw me use a couple other tools over there on the Bridgeport. I don't think I talked about them much, but I like this extra blade that fits my Starrett square. It's 45 degrees, and that's the side that I used, I believe, yeah. And I guess that's, what, 30 degrees. And that interchanges with the standard 4-inch blade, and this was my dad's. Not this blade, I don't know where I got that, but this blade was my dad's. So, you also saw me use the Starrett center finder, and this was in one of my recent videos, one of my auction finds. And the only reason I'm going to show you this, and I've talked a lot about wigglers. You know, they call it a center finder here, but most commonly we call it a wiggler. There's the body. That is the part that is used for the last word indicator. That's the one I want to talk about. And you got a point, and that's dull. Somebody dropped it. This guy was kind of rough on tools, I have to tell you. And this is this regular center finder. One end is 200 thousandths. That end is 200 thousandths. The significance being that half of it is 100. Does that mean anything to you? But this is the one that I used, and that will fit in real tight places to find an edge, and you saw me in a tight place with it yesterday. It is 100 thousandths on the little disc, half of which is 50, so that's all part of the formula when you're finding an edge in a tight spot. You don't see this one very often, that's why I'm pointing that out. Sometimes you just see these in the wiggler set, these 4 pieces. Alright, back to the tap wrench. I thought I was done talking about tools, but I'm not. And in fact, as I was putting this away, I ran into this other one. Notice that it's wider, and it is marked Starrett, and it's marked hexagon and octagon. So that's apparently the purpose of this one as well. So that's kind of interesting. I guess that goes into the big blades, or the big combination square head. Also, you saw me use this cute little Brown and Sharp. You need to have a close-up of that because it's so pretty, isn't it? That's art. That is art. Alright, back to this. This is the homemade, the top one. That's the Starrett. Set that aside. So let's put her together. I got to blow that out. It could use a little more polishing here. I draw filed it just a little bit on both sides to get the machining marks out, but in the process hit the taper just a little bit. I should have had a mask on that, but it turned out pretty well. So it is done. Now the question is, and I got a bit of a crown on there, probably not as much as the Starrett, but that does dress it up, doesn't it? Over just a flat end, and the same thing here. Alright, let's try it out here. This is a number 0 from the Great Westclox factory. But notice that even a very small tap has a bigger shank and a fairly big square shank, considering that it's a tiny tap on the end. Do I have it in there right? I gotta hold that up to the light. Let me blow that out and I'll be right back. The overall length is 3 3/4. I don't know if I gave enough dimensions or not to actually make one of these, but I did give you dimensions all the way through the project. There it is with that number 0 tap from the Great West clocks. Fits in the STARRETT box. I was considering bluing this, but I don't believe I will, with gun blue. I just feel I'm done. I could spend more time polishing it, but you know, that is not my nature to spend a lot of time polishing. It's good enough because it's a utilitarian tool. So now I got 2 of them. Hope you liked the video, but hang on, I'm going to show you one more thing before I quit here. I just thought I'd give you a close-up view of the tool that I used for making this hole. And I made the tool holder out of, well, 3/4 stock, turned down to 1/2 inch with a set screw to hold a 3/16 square lathe bit, high-speed steel. And you can see how I ground that, I think. And this point right here, the high point, is the cutting point, cutting edge. Back here is the trailing edge, so there's just a few angles ground on there. You need to start with a bit that is ground 3/16 rather than roll. So sometimes when you buy lathe bits, they are ground like this. Then they have nice sharp corners. Some are black in color and have a little bit of a radius on the corner, and that is not quite as easy to use as a blank. So try to find the right one if you do something like this. But you may spend an hour or more just making the tool to make a tool. But that's what made STARRETT the world's greatest tool maker. This is tubalcain, Mr. Pete 222, your YouTube shop teacher, saying so long for now, and I'll see you in my next video.